machine learning, the easy way to think about it is a function approximator. So you have a bunch of input data, you have a bunch of output data, and what the machine learning model is trying to do is to create a function between the inputs and the outputs. And I said that's a particular type of machine learning called supervised learning. And supervised learning is what's the most popularly used type of learning. But there's a few other terms you might have heard of. I will go through an example just to illustrate it. For example, you can think of a self-driving car as an artificially intelligent system because it's basically trying to mimic the human behavior of driving a car. So in this case, this is an example of AI in the modern case, but you can break that problem down into several machine learning problems. So in the case of the self-driving car, you can break it down to perception, prediction, planning, for example. And each of these you can think of as a machine learning problem. And for the case of, for example, perception, the goal would be to detect what the car sees all around it. So it'll be able to detect, that'll be detecting the cars, for example, around it. So that's a supervised learning problem where the input is the image or all these sensor measurements, and the output is what each of those, what's in the environment. So you have the input, you have the output, and then you're trying to create a function. And then prediction would be like after all those objects are detected, how those objects will react or behave in the next minute or so. And then once we know what the objects are and how they move, we can plan how the car is going to drive. So on the high level, it's an AI example, but you can break it down to machine learning problems. And deep learning is a subset, is a technique you can use for each of those things. So for example, deep learning has been really good at perception, so especially with image data, and deep learning is more and more used in the other two as well. So deep learning, I'm going to use deep learning and neural nets synonymously, but they are a bit different. But you can, so I'll go into this a bit in more detail. Deep learning can be thought of in several ways. So the basic idea of a neural network is it's composed of neurons. And neurons, this is what a real neuron looks like, but in an artificial neuron it's a cartoon version of it, where in the real neuron, you have a bunch of inputs, which are dendrites, and then you have a cell body going to the outputs, and you have a bunch of outputs. And in deep learning, you also have these networks composed of, and your brain is composed of a lot of neurons. And in deep learning, you have a large number of neurons as well, with a bunch of inputs and a bunch of outputs. And deep learning is anything with more than several layers of neurons between the input and the output. You can also think of deep learning as representation learning. So in the basic idea of representation learning is in the earlier layers, for example, if you have an example of an image, in the earlier layers, you'll be detecting things like the edges of the image. And then maybe two edges combine to form a corner, and then that'll be what you'll be detecting in the later layers. And then in the final layer, you'll be detecting the whole face in the example here. But we'll get back to that as well. So where did deep learning start? So the neuron was basically invented ages ago in like 1958. But then there were several developments after that, especially the backpropagation algorithm was invented in 1974 by this guy, who is Geoffrey Hinton. There was a bit of an awkward silence of an AI winter. And then in the 90s, it sort of started, this guy invented the convolutional neural net, which is what we will be learning today mostly. And the convolutional neural network is really good with images. And in 2006, 2009 was when the deep learning term was coined, and the sort of major inflection point was in 2012 with a competition called ImageNet. So before 2012, most people think 2012 is when deep learning started, and it's sort of true. But for example, in 2009, Geoffrey Hinton, who's the guy you saw earlier, this person, he did some research with Microsoft Research about voice data. So this was before the image data became popular. So after that, in 2012, Geoffrey Hinton's students basically entered this competition called the ImageNet competition. And it's a competition where there is a data set of over 1 million images. And the goal of the objective of the competition is, given these images, which look like this, you have to guess what category that image belongs to out of 1,000 classes. And before 2012, everybody uses hand-coded features, which means you sort of build some features maybe to detect corners, maybe to detect circles or spots or textures. But in 2012, you can see that there was a major decrease in the error rate. And ever since that point onwards, these days, most people use convolutional neural nets to train images. And that is what we'll be going through today. So neural nets aren't just about neurons. There are different arrangements you can make from these neural networks, and they are called different things. But at the core of it is just a bunch of neurons arranged in a specific way, or there are some variations, basically. So neural networks at its core are supervised learning models. But they do sort of leak into the other areas as well, and I'll give you a few examples of that before we break for lunch. So the first example, okay, I'll go through the convolutional neural net. So the basic idea is you give it 1 million pictures of cats and 1 million pictures of dogs, and you train the network to classify based on the input that the output should be a dog or a cat in this case. But there are other flavors. Can you guys guess which one's a real photo and which one's a fake photo? Who thinks the left one is real? Who thinks the right one is real? It's a trick question because both of them are fake. It's actually, over time, since 2014, since this particular algorithm was invented, you can see what progress has been made every year on how good it has become at generating images as well. So in 2014, it looked pretty like that. And then in 2018, I can't tell the difference. There is an app online as well where you have to guess which one's the real picture from the fake one, and it's not trivial to do that.
The person who also made this, he also released a check sheet on how to figure them out. And it's good to look in the ears, because currently GANS can't make these, and the background as well.
Yeah, normally the edges of the thing and the ears you can sort of see that looks a bit weird. And sometimes the network has like different colored eyes, for example. And there's you can do this with videos now as well, which is getting into some ethical sort of concerns. So those ones are generated by what's called a generative adversarial network. And technically, this is a unsupervised learning model because you don't actually need the labels of what you need to have as the output. What you do need is you need a data set of real faces, for example. And there are two neural networks, basically. One of them is the one that generates the faces, generates the images. And there's another neural network which determines if so you can think of the generator as you can think of it as a game between two players. The first player, the generator's job is, for example, you can think of it as a robber that is trying to print fake money. So the forger, basically. So it's trying to generate fake images that look like real money. And the discriminator, you can think of it as the police trying to decide if this note is a real note or a fake note. So these two networks play this game. The generator continually tries to generate better and better images, and the discriminator tries to gets better and better at discriminating these real pictures from the fake ones. So you play this game, and then at the end of the game, this generator would be pretty good at generating these faces. So obviously, initially, it wasn't so great, but gradually, variations of this have become very good at generating images of humans, for example. And I'll also go through another one. So in machine learning, there's also reinforcement learning. So, but you can also use neural networks in reinforcement learning. So who's heard of reinforcement learning before? What have you guys heard about reinforcement learning? Or generally, what is reinforcement learning? Yeah. Anybody else know what reinforcement learning is? So you can think of reinforcement learning as learning by trial and error, basically. So you have an agent, which is, you can think of it as a robot. And the robot or a human or whoever can take actions in the environment. So if I'm a human, a few actions I can take is move forward, move backwards, turn right, turn left, for example. And then based on that, you either get a reward or sometimes this is a cost. So if I'm walking around, if I hit something, I get a negative reward, which basically punishes that behavior. And then the state is basically what you observe. So this sort of framework is called reinforcement learning. And you can use neural nets for this as well. Because if you look at this agent, it takes a bunch of states and rewards as input and outputs an action. And you can use a neural net to output. In this case, the output is not, it's not necessarily a supervised problem. And the output is, you basically get a temporal difference. It's probably too complicated to explain. I probably won't try to explain. But recently, it's initially, the neural nets have learned to play the Atari games. More recently, it's quite old now. Who's heard of the Go playing? So it's beaten the world champion in this ancient Chinese game called Go. It's been around for thousands of years. But the quite recent iterations of that, they were able to find new types of moves that nobody sort of realized were good. And even more recently, this is OpenAI's Dota 2 bot. It's learned to play Dota 2 or whatever video game. There's another one from DeepMind that learns, what's the other game? Yeah, there's StarCraft and a bunch of, with these deep reinforcement learning paradigms. So I'll explain, so we probably, like learning all this will probably take some time, but we'll learn the foundations of it basically, which is how a basic neural network works.